Hello everyone, welcome to the day 1st of March daily LeetCode challenge, and we are going to face the easy problem today. Problem name is counting bits. We need to count the total number of bits for in a given number. Okay, as the problem name suggests. Okay, so its index is 338. Okay, so let's begin this problem. Given an integer n, and we have to return an array answer of length n plus 1, such that for each I that belongs to 0 to n, answer of I is going to store the number of ones in the binary representation of I. Okay, so you need to write down the binary representation of all the numbers that are lying in the range 0 to n, and for each number you are going to count down the total number of bits which are set, and then we are going to report the answer vector, return the answer vector. Okay, so I will explain all those with the help of examples and also try to cover up all the different type of solutions in this video. Okay, so let's begin. So the very first approach is to use a built-in pop count method. You have must heard in C++ built-in pop count. So that is going to find out total number of ones in the binary representation of a given number. Okay, so let's try to code down with this method. Okay, so we will have the answer vector int answer, and we will iterate for all the values that are been asked. Okay, so it should be like answer dot pushback underscore underscore built-in pop count I. That is going to find out total number of ones in the binary representation of the number I, and if we have done that, we are going to return the answer. So let's submit the code and check it out whether it is going to give us the correct answer or not. Yeah, you can see runtime is 6ms and it is the good code. Okay, so there are a lot of other ways also. Suppose you have the n as, let's say, 7. So this can binary representation of number is 7 is like 111. Okay, so each time what you're going to do is you're going to divide the, like if the number is odd, you can see 7 is odd, binary representation contains ones at the one at this place. So, and in the next iteration we will divide 7 by 2, it becomes 3. Again 3 is odd, you can see, that's why we are going to have this 1 at this position. Then again we are going to divide 3 by 2, then we are going to get 1. Then you can see it is odd, so there is a 1 in this binary representation. So what the basic idea is, each time we are going to divide the number n by 2, and when the number n is going to be odd, then we can say that yes, there is a 1 in the binary representation at this place. Okay, and the same thing we are going to do for every I that belongs to 0 to n. So let's take a count variable as 0. Okay, and also there will be a capital N as I, and we need to find the binary representation of this number n, like count down total number of ones in this binary representation of the number n. So what I am going to do is I am going to check it out for while n is positive, and count will be incremented by 1 when there is an odd number. Then so you can check it by n mod 2, and each time this is going to be divided by 2. And so finally count will store the total number of ones in the binary representation of the given number n. So I will push back count into our answer. So what is the time complexity of this code? Time complexity will be, you can see worst case is O of n log n, and space complexity would be, if you consider answer vector also, so space complexity would be O of n log of n, because of this one. Each time we are going to divide it by 2. So let's submit this code and check it out whether it is going to give us the correct answer or not. So runtime is 4ms, faster than 88%. So yeah, it is good. Okay, so let me talk about another solution, O of n time complexity and space complexity O of n. So this solution is totally based on the pattern. right? So what we are going to do is we are going to write down the binary representation of all the numbers starting from 0 and observe the pattern. 1, if you write down binary representation of 1, it is this one. If you write down 2, you are going to get 1 and 0. Okay, and if you write down 3, you are going to get 1 and 1. If you write down 4, you are going to get 1, 0, 1. If you write down 5, you are going to get sorry, it is like 1, 0, 0, and 5 it is going to be like 1, 0, 1. And let me add up one more, 6, 1, 1, 0. Right, so if you are able to observe the pattern between the number of ones in the binary representation of the given number I, then you are good. Otherwise, let's check it out how we can do that. So you can see number of ones is 0, and number of ones in this is 1, number of ones in this is 1, number of ones in this is 2, number of ones in the number 4 is 1, 5 it is 2, and 6 it is 2, and for 7 you will find it is 3. Okay, you can see whenever there is an odd number, number of ones in the current number is always be equal to number of ones in the, in the n by 2 plus 1. Let me write down ones of, let's say we are at number I and we need to find the number of ones in I, will be I by 2 plus 1. So that will be the ones of I. Okay, so this is the relation that I'm talking about. So you can see if the number is odd, what is the value of 1 by 2? It is actually 0. So ones of 0 is 0, and plus 1, it is actually 1. So it is giving correct answer. What about when the number is even? So this 1 factor will not come. So you can see ones of 2 will be exactly equal to ones of 1, which is 1. You can see both are matching. Okay, and what about ones of 3? Ones of 3 will be ones of 3 by 2, which is 1, plus 1. You can see 3 by 2 is 1, which is actually 1, plus 1, which is 2. And let's talk about the number 4. The numbers of ones of 4 will be exactly equal to ones of 2. You can see 1, 1. And ones of 5 will be exactly equal to ones of 2 plus 1. 1 plus 1, which is 2. And what about 6? Will be same as 3 because it is an even number. You can see 2 and 2. What about ones of 7? Will be exactly equal to 7 by 2, which is 3, which is, you can see 2 plus 1, which is 3. Yes, it is giving correct answer. So we can frame that entire thing. So how we are going to do that? So let me just erase this one. So write down first vector int answer, and it will be initialized with 0, and each time I will start from I equal to 1 to n because we have already done with the 0 part. So I will push back answer of, okay, so so for I, we need to like for the number of ones in the position I, we need to find out number of ones in the position I by 2 plus 1 plus 1 when we add 1 when I is an odd number. So what I can do is I mod 2. So it will be even, then it will be added by 0. So it will balance all that. Return answer. Let's submit this code directly. Let's see. Yeah, it is good. So runtime is 8 ms and faster than this one. So if you guys have still any doubts, you can reach out to us through the comment section of the video, and thank you for watching this video.